Hi everyone. I'm going to show you a little bit of day in the life of a mechanical engineer, specifically focusing on product development and the design cycle. I'm a mechanical design engineer and I work for a company that makes sporting goods or sporting good supplies or something along those lines. So the first kind of step in our process is figuring out what is the market need, what does the customer want. That's where the core group has some marketing person or some sort of customer-facing person, and they talk to people, they do surveys, they understand the market, and they say, hey, we figured it out. Our next new product needs to be a portable, movable stand that can hold cornhole boards, because our company already sells 10,000 cornhole boards a year, and we want to be able to sell a stand as an add-on accessory or whatever to go with that cornhole board. So that would then come to me, the mechanical engineer, and I would be kind of responsible for kind of putting a form factor, putting the shape, coming up with the design of what that stand is going to look like. So one of the main tools that I use as a mechanical engineer is CAD, computer-aided design. There's a lot of different software packages out there, but they're all very similar. So really, before I even jump into CAD, I would probably sit down and kind of sketch out a basic idea. I know that a cornhole board is 2 feet by 4 feet by about 4 inches tall. It's got a hole in the middle. And so that'd be kind of I know that kind of gives me my constraints of what I need to hold. I know it probably weighs, I don't know, maybe 10, 20 pounds. So I sketch out an idea and kind of start laying that all out. Here in our CAD system, we can actually model individual parts, and then we put them together in an assembly. So I'm going to kind of run through a little bit of that as well. And then we'll go from there. So like I said, kind of have a rough idea from a sketch that I would have created, and then I'd start modeling. So like most things, you kind of start with the base. So we're going to make this out of steel. The reason being that steel is very strong and it's actually somewhat affordable. It's not the lightest. So when we get into our design optimization, maybe we want to look at something like aluminum instead of steel, which might be lighter, but a little bit more expensive. And those are the kind of trade-offs that we'll have to get into as we refine our design. So, you start modeling the different individual parts for your design. In this, like I said, in this case, it's a lot of different shapes of tubes and brackets and different sheet metal parts. And then eventually you get to a point where you assemble them together. Again, in our CAD system, it's fairly straightforward. You start with a part and then you start stacking them up just like you would in the real world. And in this case, because it's steel, we've chosen to weld all of this together. Weld is a very good economical way to hold things together, and it's very strong and doesn't loosen over time, anything like that. So here's our initial design. It's pretty straightforward, a couple pieces of tubing, and with a little hook on the end so that you can put a couple cornhole boards on there. Just double check that we meet the requirements. We go ahead and take that model that I created of the cornhole boards, stack 2 on there, and sure enough, it holds the two cornhole boards. Now we know it physically can hold them from a size perspective, but the next step from a mechanical engineer is, will it actually hold them? Does it meet the strength requirements and those type of things? And rather than just go out and immediately start building, because that costs a lot of money, we have tools that can do analysis. Most things, they're built in a manufacturing type environment, and manufacturing or machine shops or tool rooms, they all need something called engineering drawings. So that's kind of the next step in this process. We have a design that we think is good. Now we need to be able to communicate that design to our manufacturing partners so they can actually create that part. So again, in the same CAD program, we're going to create an engineering drawing. And this is essentially just a document that shows what the part looks like and what the size, shape, what those dimensions are. Dimensions is the word for a size. So if something is, in this case, 90 millimeters long and 38 millimeters tall, so it's about 4 inches by about 1.5 inches, just to give you a general size idea. You put that on here. So then that person, whoever's making this, knows that they need to make something that is this shape. Once you get all of the drawings done for all of the parts, you send that to all of your either suppliers or your internal manufacturing, well, then they can start making the parts. They can start checking to make sure they made them to the right size, and then they can actually build your weldment. Then you actually still need to do real-world testing, because there's nothing that can fully replace with 100% confidence testing in the real world. So all of the FEA analysis that we did was great, and it saved the company a lot of time and a lot of money because we were able to essentially build and test in our